A 3 kVA single phase 50 Hz 230 by 115 volts transformer gave the following test results. That is, in OC test 115 volts, 0.6 ampere and 10 watts. And similarly in SC test 60 volts, 13 amperes and 200 watts. Calculate the efficiency at full load and the half load at power factor 0.8 lagging. So the OC test gives the open circuit results, that is, it is performed at rated value, that is, you can see this is HV side and this is LV side. So OC test is performed at LV side, so this is V0, this is I0 and this is W0. Similarly SC test, this is written as VSC, this is denoted as ISC and this is denoted as WSC. So in OC test the power obtained, that is the wattmeter reading, will always be the iron loss or the core loss or the constant loss. And in SC test this is not full load copper loss. This can be full load copper loss and it cannot be full load copper loss. So we don't know yet it is full load copper loss or not. So we will represent it by PCU X, that is 200 watts. X because it is with respect to ISC. ISC can be equal to the full load current or the rated current, what we say. If ISC is equal to full load current or rated current, then the copper loss will be full load copper loss. Otherwise it will not be full load copper loss. So full load copper loss is denoted by PCU and it will be with respect to rated current. Now to check that, we have to find out the rated current value. So we know that the OC test is performed at LV side, as the voltmeter reading shows 115 volts and is always performed at rated voltage. So the SC test, that is short circuit test, is performed at high voltage side. So how to find the rated current? The rated current can be found out by VA rating of the transformer, that will be given divided by the voltage rated at that side. If SC test is performed at HV side, so this will be HV and this the corresponding rated current will be for HV side. Similarly, if SC test was performed on LV side, so this would be LV. So the voltage rated is given as 3 kVA, so 3 into 10 power 3. And V rated at HV side is what? 230 volts. So write 230. This will bring I rated value of current at HV side. So this will be equal to 13 amperes it is coming. Now check this current and this current. If both are equal, so in our case both are equal. So the corresponding loss, it is corresponding wattmeter reading shows the full load copper loss. It is full load copper loss because it is corresponding to the rated current. If 13 amperes was not equal, that is, if suppose we got some other value here, so we have to find out what is the value of full load copper loss. But in our case we got equal, so we are not finding it. We have directly got our full load copper loss, that is 200 watts, and our iron loss, which is always fixed, is 10 watts. The case when the full load, the rated current, when it is not equal to the short circuit current, we'll see in other numerical problems. So let us solve this. Now we have got iron loss as 10 watts and full load copper loss as 200 watts. Now let us calculate the efficiency at full load and half load at power factor 0.8 lagging. Now the efficiency at any load is given as, at any load is represented by X, or the any fraction of load is given by X. It is equal to X into VA rated into cos phi, that is output power, divided by output power plus losses. This is output power, this is output power plus this is iron and copper loss, that is losses. That is the efficiency is output by input, and input can be written as output plus losses. Now we have to just plug in the values of x. Now he's telling to calculate at full load and half load. Full load means what? Full load means when x is equal to 1. Or he can also mention the 100% of load. Also he can write this also. And the second one is half load. Half load means when x is equal to 1 by 2 or 0.5. Or he can also write at 50% of the full load. This is also same terminology. So first let us calculate at full load and then half load. And the power factor is given as 0.8. Like this, I have substituted the value of 1 in x. Okay. And VA rated I have substituted as 3 kVA. 0.8 power factor is given. And iron loss and copper loss I have substituted. So if we calculate it, we are getting 0.9195, or in percentage I can write 91.95%. Simply multiply this by 100, we'll get our percentage. So the efficiency at full load is 91.95%. Similarly, let's find at half load. Like this, I have substituted 0.5 in the place of x, and now I am getting 0.952, or in percentage I can write as 95.2%. So the efficiency at half load is 95.2%. Okay, thank you.